Imagine if you woke up one morning and found that you were the only person left on Earth. No friends, no family, no neighbors, nobody. You would probably feel incredibly lonely and wonder what happened to everyone else. Now imagine that you looked up at the sky and saw that there were billions of other planets out there, some of which might support life. You might wonder if there are other intelligent civilizations out there, and if so, why we haven't made contact with them yet. This is the Fermi Paradox, and it's one of the biggest mysteries in science. It is a fascinating and perplexing question that has kept scientists and philosophers awake at night for decades. The Fermi Paradox is named after physicist Enrico Fermi, who first posed the question, "Where is everybody?" in 1950. The paradox asks why, given the vast size of the universe and the high probability of the existence of extraterrestrial civilizations, we have not yet made contact with any of them. This paradox has puzzled scientists and philosophers for decades and has given rise to numerous potential explanations. To understand the Fermi Paradox, it is helpful to first consider the vastness of the universe. Our own galaxy, the Milky Way, contains an estimated 100 billion stars, and there are an estimated 100 billion galaxies in the observable universe. Based on these numbers, it seems likely that there are many other planets out there that could support life. In fact, recent discoveries of exoplanets in the habitable zone of their host stars have only strengthened this hypothesis. So, if there are so many potentially habitable planets out there, where are all the aliens? This is the heart of the Fermi Paradox, and there are several potential explanations that have been proposed. One possibility is that intelligent civilizations self-destruct. This could happen for a variety of reasons, such as war, environmental destruction, or technological mishap. We have certainly seen examples of such catastrophes in our own history, such as the Chernobyl disaster or the Tunguska event. It is possible that other civilizations have suffered similar fates, preventing them from ever making contact with us. Another possibility is that the distances between stars are simply too great for us to make contact with other civilizations. Even if there are other intelligent civilizations out there, they may be too far away for us to detect their signals or travel to their planets. This could be due to limitations in our technology, or it could simply be a consequence of the vastness of the universe. A third possibility is that we are simply not looking in the right places or using the right methods to detect other civilizations. For example, we may be searching for signals in the wrong frequency range or looking for civilizations that use technologies that are vastly different from our own. It is also possible that other civilizations are intentionally hiding their signals or avoiding contact with us for some reason. Yet another possibility is that we are alone in the universe. While this may seem unlikely given the vastness of the universe and the number of potentially habitable planets, it is still a possibility. Perhaps the conditions required for the evolution of complex life are rare, or perhaps the emergence of intelligent life requires a very specific set of circumstances that are unlikely to occur elsewhere. There are, of course, many other potential explanations for the Fermi Paradox, and the truth may be a combination of several factors. However, regardless of the answer, the Fermi Paradox reminds us of the vastness and complexity of the universe and the many mysteries that still remain to be solved. As we continue to explore and study the cosmos, we may yet find answers to this and other perplexing questions about our place in the universe. What would happen if you went back in time and killed your own grandfather before he had children? I mean, if you did this, you would prevent your own existence. But if you never existed, then how could you have gone back in time to kill your grandfather in the first place? Scientists call this the grandfather paradox. It's a well-known paradox in science fiction and time travel stories that raises questions about the possibility of time travel and its potential consequences. One of the key issues is whether time travel is possible at all. According to our current understanding of physics, time travel is not possible, since it would require the existence of closed time-like curves, which violate the laws of causality. However, there are a number of theoretical models that suggest that time travel may be possible under certain conditions. For example, some physicists have proposed the idea of wormholes, which are hypothetical shortcuts through space and time that could potentially allow for time travel. Others have suggested that time travel may be possible using black holes or other exotic phenomena. Assuming that time travel is possible, the grandfather paradox raises further questions about the nature of causality and the possibility of changing the past. According to our current understanding of physics, the past cannot be changed, since everything that has happened in the past has already caused the present. However, if time travel were possible, it would open up the possibility of changing the past, leading to the paradoxical situation described by the grandfather paradox. Some people have tried to solve this paradox with the idea of the many worlds interpretation of quantum mechanics. According to this interpretation, when a time traveler goes back in time and kills their own grandfather, a new branch of the universe is created in which the time traveler never existed. This avoids the paradox by creating a separate timeline in which the time traveler's actions do not affect their own existence. Now, despite the many theoretical models and proposed solutions, the grandfather still remains a challenging and unresolved problem. Ultimately, the grandfather paradox serves as a cautionary tale about the dangers of messing with the fabric of time and space. While time travel may seem like an exciting prospect, the potential consequences are far-reaching and difficult to predict. This statement is false. Now, if this statement is true, then it must be false. But if it is false, then it must be true. This creates a paradoxical situation called the liar paradox. The liar paradox is a particularly interesting paradox because it highlights the limitations of language and our ability to use it to describe reality. It also raises questions about the relationship between truth, meaning, and reference, and has implications for our understanding of semantics and logic. One possible way to understand the liar paradox is to analyze it in terms of its underlying assumptions about language and truth. The statement, "This statement is false," assumes that truth is a property that can be consistently assigned to propositions, and that language can be used to accurately describe reality. However, the liar paradox shows that these assumptions may not always hold true, and that our understanding of truth and language may need to be reevaluated. Another way to approach the liar paradox is to consider its implications for logic. The liar paradox shows that there may be statements that cannot be consistently assigned a truth value using the traditional principles of logic. This has led to the development of new theories of logic, including pair-consistent logic and dialtheism, which argue that it is possible for some statements to be both true and false. These theories challenge our traditional notions of logic and require us to rethink our assumptions about the relationship between language, truth, and reality. Attempts to resolve the liar paradox have been ongoing for centuries, and many philosophers and logicians have proposed various solutions to the paradox. Some have suggested that the paradox arises from a misunderstanding of the nature of truth, and that truth should be understood as a pragmatic concept rather than an objective property of propositions. Others have proposed more technical solutions, such as revising the principles of logic or introducing new rules for assigning truth values. This paradox arises when considering whether humans have free will or whether our actions are predetermined by factors such as genetics and environment. If we do have free will, then it seems that our actions cannot be predicted. But if our actions are predetermined, then it seems that we cannot have free will. This paradox has important implications for moral responsibility and personal identity. The paradox arises from the tension between our subjective experience of making choices and the deterministic nature of the universe, which suggests that everything that happens is determined by prior causes. This has been debated by many philosophers and scientists for centuries, and it remains a complex and unresolved problem. At its core, the paradox raises fundamental questions about the nature of reality and our place in the universe. To approach the paradox of free will, you need to examine the different perspectives on the problem. From a philosophical standpoint, the paradox of free will can be seen as an issue of determinism versus indeterminism. Determinism suggests that everything that happens is caused by prior events and that there is no room for free will in a deterministic universe. Indeterminism, on the other hand, suggests that there are some events that are not causally determined and that free will may be possible in an indeterminate universe. From a scientific standpoint, the paradox of free will is related to the idea of causality and the nature of the universe. According to the laws of physics, every event is caused by prior events, and there is no room for free will in a purely deterministic universe. However, Recent advances in quantum mechanics have suggested that some events may be indeterminate, and that free will may be possible in a probabilistic universe. Despite these different perspectives, the paradox of free will remains unresolved, and there is no clear answer to the question of whether humans have free will or whether all of our actions are predetermined. What do you think about the paradox of free will? Do you believe that humans have free will? Leave your thoughts in the comments below. If the universe had a beginning, then what existed before the universe? And if the universe is eternal, then how can we explain the origin of existence itself? The question of existence is one of the most profound questions that humans have asked themselves throughout history. It is a question that has been addressed by philosophers, theologians, and scientists in many different ways. But the paradox of existence raises a particularly difficult problem. As I said before, if the universe had a beginning, then what existed before the universe? And if the universe is eternal, then how can we explain the origin of existence itself? One way of approaching this paradox is to look at the scientific evidence for the origins of the universe. According to the Big Bang Theory, the universe began as a singularity, a point of infinite density and temperature around 13.8 billion years ago. This singularity then rapidly expanded and cooled, forming the universe as we know it today. However, this theory does not explain what caused the singularity to come into existence or what existed before it. Another scientific theory that attempts to explain the origins of the universe is the concept of a multiverse, where there are many universes existing alongside each other. The idea of a multiverse is supported by the theory of cosmic inflation, which suggests that the universe underwent a period of exponential expansion shortly after the Big Bang. This theory proposes that the universe is one of many possible universes, each with different physical laws and constants. However, the concept of a multiverse raises its own set of paradoxes and questions. For example, if there are multiple universes, how do we explain the fact that we exist in this particular universe with these particular physical laws and constants? And if the multiverse is infinite, then are there an infinite number of versions of ourselves existing in parallel universes? On a philosophical level, the paradox of existence raises questions about the nature of being and the concept of nothingness. If the universe began with a singularity, then what was the singularity made of? And how did it come into existence? And if there was nothing before the universe, then how can we even conceive of the idea of nothingness? The paradox of existence is a deeply philosophical and scientific problem that challenges us to think deeply about the nature of existence and the origins of the universe. While we may never have a definitive answer to this paradox, it reminds us of the limits of our understanding and the profundity of the questions that we ask ourselves.